Right, this will be the last video for subtopic 4.1 circles. So the fifth learning objective here is just to find the length of the tangent from a point to a circle by using Pythagoras theorem. Okay, let's have a look at this question. Find the length of the tangent from the point, okay, from the point to the circle. I think you should highlight this word, from the point to the circle. Okay, we are going to find the length of the tangent from the point to the circle. Let me show you the picture. We are going to find the length of the tangent. This is the tangent, guys. You know the tangent means always touching the circle. We know that. The tangent always touching the circle, and now we are going to find the tangent line, the length of the tangent from a point to the circle. As long as it touching the circle, it's enough. And so it's point P. I mean, it's like the distance is PQ lah. I label it as PQ. Okay, we can use any labeling. This is just an example for you all. Okay, so basically this is the length that we want. This is our major goal. This is our huge goal here, which we want to find the length of the tangent from a point P to the circles that touching the tangent line. Okay, so here we go. How do we do it? So step one is just compare this with the GE. Okay, compare it with the general equation formula, which is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So I compare it, I got my g is equals to -2. I compare it, I got f is equals to -1. I compare it, I got c equals to -6. And so I subs into the coordinates of the center here, which is -g, -f, and so I got +1 and +2 and +1 for my coordinates of the center. This is very, very important to chart. Every time kita cari G dan F, bermaksud kita nak automatic, kita nak center. Okay, so kalau nak cari radius pula, okay, we need the radius, it's very important to find center and radius. So we need the radius, we use this formula, which you must memorize this, g squared, square root of gx, square root of g squared plus f squared minus c. You sub it in, and then you got the square root of 11 units. Okay, this square root of 11 has a value, it's not has a value, it is a value. So square root of 11 is actually 3.32 units. Okay, it's a length. It should be a positive. So the radius is 3.3 centimeter lah, contoh. Okay, so why do we need this radius? Have a think. Why do we need this radius? Kenapa perlu cari the length of the radius? For what? Okay, for if we have this radius, okay, let me use different color now. So if we have this length of the radius, and then of course, if we have this radius and we have this line, the hypotenuse line here, okay, of course we can find our goal, which is we want to find the length of the tangent from point P to the circle. That is our goal. And so our steps is first to find the circle, and then to find the length of the hypotenuse here, which is I denote it as CP. But you don't have to follow the word CP anyway. I use a different alphabet here. So I use here radius. So my radius here, which is the square root of 11 ataupun 3.3 centimeter or meter, whatever. And then I use the length of the CP just now, I denote it as H. I use the H. It's easier for me anyway. Okay. So I need to find this H first. I need to find this length of the hypotenuse first barulah saya ada hypotenuse, I got this line, and eventually I got my goal, which is the length from the point, the length of the tangent from the point K to the circle. The circle is here, guys. Kalau saya nak lukis juga kan, the circle is here. I hope you understand. You can compare it with my notes there. Okay, so now is to find, after we find the radius, after we find the radius, we can find our h. Okay, our h, which is the distance from point K till point C. So the distance from the point K to point C is just by using a formula. The formula is the square root of x2 minus x1, the whole thing squared. That's why I put here 4 minus 2. 4 minus 2, the whole thing squared. And then y2 minus y1, the whole thing squared, which is 6 minus 1, the whole thing squared. I got the square root of 29. So the square root of 29 bernilai 5.39. So here is square root of 29, which is 5. So logik ke tak logik bahawa sini adalah apa tadi? 3 point something lah. 3 point berapa tadi? 3.32. So of course lah, yang ni nampak lebih pendek kan? 3.32, and this is quite long, isn't it? 5. So what do you expect for this length then? I think I expect this should be 4 lah, 4 point something. Let's see whether it's correct or not. Okay, so now the next step will be just using the Pythagoras theorem, nothing much. You know Pythagoras theorem because this is right angle triangle. Okay, so bolehlah cari, kita dah ada hypotenuse line, kita dah ada radius dekat sini, dan kita boleh Pythagoras theorem untuk cari kita punya length of the tangent. So the length of the tangent I denote it as huruf D, okay? Saya pakai huruf D, senang lah. So the length of the tangent I denote it as D. So my D is eventually the square root of 29 minus 11, okay? Which is the D, the tangent of the line, the length of the tangent. The length of the tangent adalah bernilai sebanyak 3 square root 2. So 3 square root 2 sebenarnya adalah 4. See? 4.24 cm. So logik ke tidak? Ini adalah 4.24 unit. So this is like 3 units. This is sort of like 4 units. 3 units, 4 units, and here 5 units. Because this is, of course, daripada gambar ni pun, diagram ni pun dah nampak ini lebih panjang. Of course, we know the hypotenuse line is the longest out of here and here. See, it's logic there. So it's just using the Pythagoras theorem, nothing much. All right, so here we go. The D, I denote the alphabet B, the alphabet D donkey as the length of the tangent. Okay, lebih senang pakai satu huruf sajalah instead of pakai yang ini panjang-panjang ni. Tak perlu pakai yang panjang ni, tak perlu pakai PQ or CP. It's okay. You can use the short alphabet there, which is the just D over there. All right, you can use that as well. So the next final example here is just find the length of the tangents from the point. Again, soalan sama, bentuk soalan sama. Find the length of the tangents from the point here to the circle with the center. Oh, now dia tak bagi equation of circle. Dia bagi center terus. This is much more easier sebab dia dah bagi center and dia dah bagi radius. So radius kita lagi cepat. Kita dah ada radius 2 units. So we are so happy our radius is given from the question, lagi cepat, lagi laju untuk cari D here, the length of the tangent here. Okay, so we are given the center. Okay, so our job is just to find the distance of the hypotenuse here. Okay, so find the distance of this hypotenuse by using the formula of the distance, x2 minus x1, the whole thing squared, blah blah blah. You know it. You sub in 8 minus 3, the whole thing squared, 4 minus 0, the whole thing squared. And you will get square root of 41 unit, which it costs you 6.4 unit. 6.4 unit. So this is actually 6.4, sorry, 6.40 unit. Okay, so it's logic lah. The radius is much more smaller than the hypotenuse. All right, so this is 2 units, this is 6 units, 6.4 units. So how about this then? I bet this will be like 5, no, 4 or 3, I do not know. So let's find this D by using Pythagoras theorem. So I just sub in my radius first. So Pythagoras theorem, I think you know this already, right? So Pythagoras theorem is just the radius, the length of the radius, the length of the radius squared. So 2 squared plus with the D squared, we do not know yet. So R squared plus D squared equals to H squared. So sub in whatever you have it, which is only the radius and the H distance there. And you got the D there, which is the square root of 37. So the square root of 37 is just 6 point, wow, what is this? 6.0. 6.08, guys, 6.08. Wow, okay, yeah, 6.08, 6.08 centimeter. Okay, it's almost close to the hypotenuse, but it is still smaller than the hypotenuse longest line here. So we are fine then. As long as this is less than 6.4, it is good. It is just correct anyway. So yeah, that is our answer. So it's not that hard to find this to find this line, the tangent line there, the length of the tangent line from point P to the circle. Thank you very much.